coming at you with another AP chemistry video. This time we're going to be looking at moles. So what is a mole? A mole can be defined as 6.022 times 10 to the power of 23 atoms. This is important for us because in chemistry we don't use grams, we don't use weight, we use moles. And mole are the only thing that's they're the only way you can get stuff done in chemistry. And why is that? It's because chemistry has these things called elements. So we have hydrogen, helium, and so on. Hydrogen has only one proton. Helium has two protons and two neutrons. Um, neutrons there, and these two neutrons and protons add extra weight. This one's 2p, 2n. This one has only 1p. These add a lot of weight when it comes to how much volume it's taking up. Because one liter of hydrogen is not going to weigh the same as 1 liter of helium. The helium will be much heavier because it's occupying a less amount of volume and has a larger molar mass. It's got an extra proton and two neutrons, whereas hydrogen only has one proton. Now we're gonna look at, if we get onto our problem again, we're gonna look at molar masses. So a molar mass is basically how much does 1 mole weigh. So 1 mole of hydrogen weighs or has mass of 1.008 grams. Atom of hydrogen, so a mole of oxygen, has mass of 16.00 grams in 1 mole. So 1 mole of water is going to equal to 16.00. We only have 1 hydrogen and 2 hydrogens since it's H2O. 0.008. And this is going to give us roughly 18.016, which is going to be 18.02, because we pay attention to sig digs, grams per mole as for water. Now, this is the molar mass of water that we just derived from here. Now, let's move on to this example here. The solution is prepared by adding 16 grams of methanol, CH3OH, which has a molar mass of 32 grams per mole, to 90 grams of H2O, which has a molar mass of 18 grams per mole. So here you don't want to derive the grams of mole yourself. You want to use what's given in the problem, and that's it. Don't try to do other things when it's given here. So let's find the amount of moles in 16 grams of methanol. 16 grams of CH3OH. And here we're going to do a conversion factor. The total molar mass they already give us is 32 grams of CH3OH for 1 mole. We eliminate grams to give us moles. This would give us 0.50 moles. CH3OH. Let's find out amount of moles in 90 grams of water. I'm gonna give us this 18 grams of H2O. We'll cancel out the grams like we did with methanol, and we'll get about approximately 5.0 mole of water. So now let's find the mole fraction. The mole fraction of CH3OH, here in chemistry we use a symbol called X, of CH3OH is going to equal to the total moles of CH3OH we have right now, which is 0.50 divided by 0.50 added with 5.0, which is going to give us 0.091 moles, or sorry, no, 0.091 as our mole fraction of CH3OH. Let's move on to another example. Asked to see how many carbon atoms are in 2.8 grams of C2H4. Atoms in C2H4. So in chemistry, remember, we always go from grams to moles to atoms, or the other way around. There's no way to ever go from grams to atoms, and that's why we have the mole. So now let's see how many atoms are in C2H4. Specifically 2.8 grams. Let's convert these grams to moles, so 2.8 grams C2H4. This problem doesn't give us molar mass, so we're going to have to derive it ourselves. So we're going to have to add the molar masses of 2 carbons and 4 hydrogens. We'll say 1 mole of C2H4 has the combined molar masses of 2 times carbon, which is about 12.0, added with 4 times 1.008. I'm using a very simplified periodic table here, so I might be off by a few digits depending on your answer. But let's keep continuing this. Grams, we're going to cancel out the grams here. Now we're left with moles. So now we need to cancel out the moles of C2H4. 1 mole of C2H4, like any mole, has 6.022 times 10 to the power of 23 atoms. However, it is important to note this will give us the atoms of C2H4, not the atoms of all the carbons. For the carbons, we're going to see that we have 2 carbons. It's for 1 C2H4. We'll just have to multiply it by 2 because, C2H4, we have 2, whereas we only have 1 of these. So now let's do our calculation. The answer for this one you should get is 1.20 times 10 to the power of 23 carbon atoms. Here. Sorry, my handwriting is a little bit messy. Now we're going to move on to another example. Let's do it for this one. We have 0.45 grams of iron, and we're asking to find how many atoms are. Remember, we can never go from grams to atoms. Grams to atoms, we cannot ever do this. Go from grams to moles to atoms. This, I need you guys to really set into memory because this will help you at least find some sort of the correct path. And even if you get the wrong answer, chemistry teachers generally give you partial credit if you show the right process. Anyway, so 0.45 grams of iron. We're going to multiply this iron by its molar mass. So 1 mole of iron has a total molar mass. Actually, let's not refer to it as molar mass. 1 mole of iron has 55 0.85 grams. Weighs at least that many grams. 1 mole, and 1 mole of anything will have 6.022 times 10 to the power of 23 atoms of Fe. And this is going to give you a total of 4.85 times 21. 21 atoms of iron. So this is your basic conversion tables from atoms to moles to grams. I hope we were some help today. Please come back another time to go over molarity, electrochemistry, and thermochemistry. Thank you for watching. Don't forget to subscribe and drop a like for future videos.